Yo, what's up? What's up? So let me just reiterate the plan for this week, and we will see how well we can execute it. So last week was a lot of experimentation and figuring things out with Tessellation, trying to work with it in the best possible way for both visual and performance. And I think we have arrived at something that definitely will improve multiple different parts of our game. I'm talking about the ground rendering, the water rendering, and weather effect like snow rendering. So we're actually going to try and apply this to the snow today and see how it looks. The thing is, before we apply it to the ground as well, I really want to make sure that we solve one of the biggest problems with this, and that's the collision. So, like doing the normal calculation and actually doing all of the offsetting and normal and stuff on the GPU and not on the CPU means that we don't have a mesh to do collision with on the CPU. And I wonder if one could implement like a height map collision type of thing. So we're gonna look into that this week as well, and hopefully by the end of this week we have all the new implementation and knowledge we've gathered here implemented and used in the old terrain system. Like this will improve the performance for sure, but we mainly did this because of the visual improvement. So we had some topology visualization problems for the displaced mesh, especially in corners where the slope of the mesh aligned with the topology of the mesh. Got a little bit of a jagged result. But anyway, let's see here. So in the end, we go with not the texture that is... so if we choose to have a terrain that is n times n original vertices, our texture is going to be n to the power of 2 plus 3 at its higher resolution. And that's because we want to have the neighboring heights as well, just the edges, so we can get a nice seam. One thing, however, I want to displace this back. I don't know why it isn't displaced right now. And then I wonder what the fuck is going on here. I wonder... let's try and do this. Yeah, one thing as well, this new height map solution works with a texture with higher resolution as well, or more bits for our height. So instead of going with R8, we have R16. So we can display way more we have to do point here, so we can display way more different heights. That's good. So what I'm wondering is, the data looks to be all right. Or actually, it's not. Yeah, we just offset 1/2 pixel here. That's not good. We want to offset 1.5. Thought we fixed this. Step test. We do +3 here. Height map texture size. What I would like is We want one more pixel here. 1.5 offset should be enough. So I thought, let's see here. Zero. Oh, yeah. We do... Okay, that's good. We do this here, so we set the outer bounds to black. Okay, that's beautiful. So it's actually like... Let's quit that. Let's hide that. And let's take a look again. If we rely, or in the cases where we rely on MIPS, it's going to be a little bit weird. But in the cases we rely on MIPS, it's usually for more broad calculations. We don't expect a perfect result. Because when we try to downsample a n to the power of 2 plus 3 texture, it's going to be a little bit weird. But let's see here, 1.5. So if we have an offset of 1.5, we have 1/2 pixel hidden and 1 full pixel hidden. Okay, that's beautiful. And let's see what kind of normals we get with this. Okay, now we got beautiful edge normals as well. That's great. Okay, let's add back the displacement as well. Before we move on to adding this to the snow, I want to experiment with the fading of the... So I want to experiment with the dynamic tessellation as well. So less vertices when we're far away, more vertices when we're close. Okay, this looks great. Right now, our new vertices, so let's see, split, quad, 0. Yeah, we have a lot of new vertices. Right now, all of these vertices are basically located on one plane, so we don't offset for this one yet. We're gonna do that now. Let's do that first, or have I just disabled it? Calculate new points, yes. So if we don't split, so our split is basically, it's the last it's the last tessellation, but we also add a few more points, some additional points. So this point right here, for instance, it's located between 4 different pixels. What we could do, we could probably use some sort of tessellation to maybe even peak this a tiny bit. I don't know exactly how we want to handle it. But this is definitely good enough. I just want to see what kind of resolution we have here. I think we're at 128, but I'm not sure. So we do... resolution is 2 to the power of subdivision plus 1. Alright, and when we tessellate it later on, it's going to be this. So subdivision plus 7. Our subdivision is at 0. Yeah, beautiful. So we get this from 128, 128. You can see a little bit of some normal artifacts here. Doesn't look too great. Then again, tessellation mesh creation. Not this one. Is it quad test? Did I screw up this time to get this artifact again? UV step. Yes, okay, nice. So we have this shading issue, and it's just because of the fact that test is 0.44. If it's 1, we get perfect. Okay, nice, we're back. We still get a tiny bit here, but I mean... so... does this one at certain places, I would hope. Here. But I'm okay with that. Yo, what's up, Cooler SK? Hope you had a wonderful weekend. Okay, so let's see. We are gonna add... We're gonna remove test from here, and we are gonna remove... That was the only place, and then we're gonna do... We're gonna calculate 2 different points here and interpolate between them. So we're gonna do... We're gonna do it like this, and let's see here. UV position in world space doesn't change. Or actually, it changes, but in height, and then we want to do these two. Okay, let's do it like this. Let's see, position clip space, normal, U direction, UV. I wonder if we can do final point is equal to interpolated point. And we do final point dot position. Trim world space, clip space, and then we want normal and view direction as well. We get something like this. We calculate a interpolated point and a final point. And for now, what we're gonna return here is lerp. between interpolated point, final point, and we're gonna go with test here for now. So 0, this we return interpolated point here, 1 we return final point, and then we do a linear interpolation between them. For everything else, fuck, can't we lerp these two? Yeah, they are structs. I guess we can interpolate it ourselves, or calculate it in a better way, so we don't create two domain shader output, we just create one, but we lerp between. Do like this one though. Let's see here. Lerp result, that's not a good name. Just name it output. Which means we probably don't need position CS here. So we work with domain shader output here. Eventually, depending on... Oh, fuck. It depends on what shader we are in. So for like the snow shader, I would like this one to be replaced by rain snow. I would like that one to be replaced by... Where do we have it? Snow vertex, eventually. So we just package a lot of different data in a struct, and we do a lot of work on it, and then finally, at the end, we convert it to X shader output. But so in the snow shader, that would be snow vertex, in the water, that would be water vertex or whatever. But the thing is that a lot of this, so the vertex shader, like best case scenario, what I would like to do is I would like to put the vertex shader, hull shader, patch constant function, and domain shader. I would like to put all of those into a separate file. So when we want to do tessellation, if in the future, we just include that one. Problem being, this one, yeah, all of these, honestly. So we're gonna have to give this one a generic name, and then whatever file is including it is gonna have to define it, I guess. This is gonna have to be some sort of method, maybe. I don't know if we can make it generic enough to implement it in multiple different places. Yeah, so something like this would be amazing. I guess we can do the tessellation, we can probably do. Yeah. Yeah, because in the file in question we could do wonder if we can do compiler macro for if and def. We redefine those. Maybe. Don't do anything weird here, nor here, nor here. Or here. We start doing, this is where we start, we do some we can probably do it, but we're gonna complicate it a bit more before we do it. LERP domain shader output position world space. We can see here also that, so both position CS, view direction, world space, we don't really need those calculated here. Because we don't... I mean, we could lerp them here as well, but this is probably the better way. Output dot position vs. Yo, what's up, Radiant? Hope you had a beautiful weekend. How do you have a browser in VS Code, by the way? Microsoft Edge tools in VS Code. Initially I hoped that GitHub pull requests plugin would solve it. It does give me some GitHub functionality, like this, but not much more. I wanted to be able to read and write two issues, so I found this solution. I mean, it's not perfect. It's a little bit slow and stuff like that. Doesn't render at the correct resolution, but whatever, it works. Lerp domain shader output, save normalize, and then we just do output dot UV. We don't really need to lerp this one either. So we do a lot of unnecessary calculations here, but for now I'm okay with it. We're gonna clean this up a ton today. So what we do down here eventually is we're always gonna split quads, so I don't care about this anymore. Oops. Create point from, and then we'll return lerp domain shader output. We have a compiler error. Yeah, we might want to do return output here as well. And let's do selection wire, and let's see here now. So now we have test here, and we can slide it down to 0. So basically we have this much topology right now, but all the new points, so that means one extra subdivision and the middle points. So this one is one full quad, and all the new points here are this one, this one, this one, this one, this one, this one, and this one, as well as this one, this one, this one, and this one. We generate these new points, but the position and all the properties of these new points are pretty much just interpolation between these 4 points. Or for this point, or we can start with this point, is just an interpolation between this point and this point. And at this point is just an interpolation between this point and this point. This point is just an interpolation between this one and this one. But then if we bring up So test is our parameter to the interpolation method. So we can, if we tune this one up, we can see that these vertices now gets placed at their correct position. So the idea is that the camera moves closer to the mesh and a set of new points pop in, but we don't displace them. So we don't get any popping. But then as we move closer and closer and closer, this one adjusts to the new points, which will hopefully lead to sort of a fading result, which is like we're not gonna do the interpolation when the camera is this close, but if we have something far away and we move towards that point, we're hopefully not going to see any popping. That is the idea. If I can hope this works and looks beautiful. And once again, so previously we handled this in the tessellation shader, the interpolation between points, and it was extremely tedious. We needed to do some weird calculations to figure out which points are new and so on. This time around, we do it in the geometry shader. We know that all of these points are new ones, or we're gonna make sure, we're gonna double check. It might be that 2 of these are actually old points. We're gonna double check that before we start. So we're probably gonna send in a interpolation value here, I reckon. Or we're gonna calculate a position. Well, let's see. This is actually turning out real nice. I like this. The only thing I'm not really a big fan of over here is probably this stuff. That we do this in 3 strips. But I don't know if we can do it in viewer. But that's a future me problem. What we're doing right here, actually, this improvement, was once upon a time a future me problem as well. Okay, so I'm actually going to commit this one, but I'm a little bit... I hate that I removed one thing here. Let's see. We want to try some things out with this one right here. So I'm gonna want to return just the original one here. So we're gonna do Let's do it here. Okay, if we can get this one to work. Okay. I'm just gonna commit this real quick. We're gonna rename it as well. And we're gonna do so to start doing some distance-based tessellation. So the idea is that split quads 0. Okay, so the mesh looks like this. Looks okay from far away. And then when we move closer, we get this subdivision, but we don't get no interpolation of the new point, so we get this. And then as we move closer, we interpolate more and more and more and more, finally resulting at this smooth surface. And I just have to say as well, I like how well this renders, because like I have to state once again that this is 10 times 10 meters represented by only 128 data points. I think for the final or in game, I think we're at least gonna double this. So that's very nice. Okay, let me just commit this one. I wonder, however, terrain tessellation quad test. We are just gonna name it terrain tessellation test. And then I think I'm finally ready to remove these. Line test, this one never did anything good for us. Triangle test. Triangle tessellation gives us... I mean, it's very nice. I think it results in good topology, but it's not structured enough for our use case. That is the biggest problem. Love this. We just have to check. The structure we have enforced is beautiful. If we think about... What is it? Yeah, we have such a structure to our tessellation and topology that when we later on, when we revisit the procedural grass shader, make it look a little bit more visually pleasing, more cartoony, I suppose. And then we can properly implement grass fading in and out as well. So we're gonna, when we spawn grass, depending on tessellation and distance from camera, we're gonna position it halfway down the ground. So instead of grass popping in, we're gonna have grass growing out. I think it's gonna be beautiful. So yeah, we have solved multiple problems past me, pushed on to future me. That's very nice. Brilliant. That my brain hurts. Honestly, I'm getting a bit nauseous myself watching all of this. I'm tired as hell on it, or off it. So it's feeling real good that we're at the end game now. Hopefully, like if we manage to implement this in a very nice and generic way, in such a way that we can just have a util tessellation file we include in every shader that is going to tessellate in some way, it's going to be amazing. So in the future, when we want to add a new shader that wants to do this structured tessellation, we just do include util tessellation and everything is done for us. We just have to use some method here. Yeah, it's gonna be great. I think we're probably gonna end up with... Yeah, so... We're probably gonna call whatever we get into geometry shader as like tessellation point or something like that. And then we handle this as well in a different file. Yeah, I think it's gonna be great. But we're not done just yet. So what did I want to try? Yeah, I want to commit this one. Terrain tessellation test. Terrain tessellation triangle test made us understand, or especially me, how triangles tessellate. Radiant humanity will thank you in 100 years, bro. Maybe a few people at least. So I think what we're doing here right now is... I don't think it's anything new, but if you look at most, or if all the sources I've been able to find online, they don't really cover these specifics, but I'm pretty sure this has been done multiple times on different closed source repositories over the world. But yeah, I definitely think this will make a nice video eventually. Maybe even a write-up. We will see. Quad test comparison and comparison 2. They were just Unity solutions that we wanted to compare with. Okay, terrain tessellation test. I'm gonna commit this file right now, but this is not gonna be a file that is around forever in our repository. Eventually, whatever closes off this issue is gonna remove this file. So we're gonna work with it, and eventually we're gonna transfer it to a utility file. Something like that. But I think in its current state, yeah, we have a few of these that we might not need. Shadowcaster. try this one. Or actually, this one is a no-brainer. So Shadowcaster, it just works with position, if I'm remembering correctly. Let's see if we get some nice shadows here as well. But to get shadows, we need to do util lighting, shadow amount. Let's go with 0.5. Can we get any shadows here? If we change the height. Yeah, we have shadows here. But honestly, they don't look that great, do they? Huh. Or actually, I think they do. Radiant, by the way, how about the normal trouble of the other the day you achieved a solution? Yeah, the problem was we finally compared it to Tessellation mesh creation. We created another mesh, and in this one we do recalculate the normals using Unity solution on the CPU, and it actually gave roughly the same result, which made us look into the height texture. And our initial height texture could only represent, we stored height value in 8 bits. So our original height texture could only represent 256 different heights, something like that. And that was what messed up our normals. So you had a high resolution mesh, but you only had 256 different height values. So by representing the height values with 16 bits instead, so that we can represent way more different heights, or finer height differences, actually fixed our normal problem. So it felt very nice to get to the bottom of that one, because that one sucked. But okay, we have shadows as well, so let's just commit this one real quick. And then we can start adding dynamic tessellation. Yeah, I might have wasted a tiny bit too much time on thinking we were doing something wrong in our method, but I had never seen that type of normal artifact before. It was very, very frustrating, but felt great to finally solve it. Okay, so let me just commit this real quick. I also want to rename... Oh, we have a lot of materials now, I reckon. Materials, terrain tessellation, line, comparison. Okay. Okay, let's see here. I want to add Yo, what's up, Spios? Was just in the middle of a commit, so didn't see it. You too, and thank you for the raid, appreciate it. What's up, Julian? Okay. Here we go. Add experimental tessellation shader. Okay, great. So this one works beautifully. I'm just gonna run and grab a drink. One sec. Okay, back. Sorry about that. Julian, can I see the creatures? Unfortunately, no. They only exist on paper at the moment. But we're gonna do some. We're gonna do some game logic implementation soon enough, and I'm thinking about including some creatures in that. Is it a battling game? No. You will probably be able to compete with the creatures, like in races and, I don't know, fashion shows. I don't know if like games like Chow Garden or Viva Pinata rings any bells for you, but it's very, very relaxed and not... very little, if any, violence. Tessellation mesh creation. I didn't commit this one because, yeah, I don't want that one littering my repository, because that one is going to be removed. It's not going to be merged into any existing file. Okay, let's do some view distance based tessellation. We have done this a few times before, not this structured, however. Tessellation. Okay, so it's a question of how we want to define this. I'm thinking of defining it. Previously, we have defined it as two vectors, basically. One that specifies the minimum amount of tessellation, and one that specifies the minimum and maximum amount of tessellation. And one that specifies the minimum and maximum view distance. So, but with this more structured tessellation approach we use now, the max is always, like the max tessellation amount, this one right now, I think, is always going to be tied to the actual resolution of our data texture. So I'm thinking of just having distance. tessellation bounds. Actually gonna call it tessellation distance bounds. Yeah, I think that's good. Tessellation distance bounds, and it's this one we want to change. So if we do view vector center, yeah, we can probably go with this one. But I wonder if we want to we can start by okay, so with all the knowledge we have gathered, we can start by tessellating it based on center view vector, but eventually we want to base it on each of these points. So we have a quad here made up of 4 points. Oh, I drew this somewhere, but I don't think we have it left. Did I actually delete that notepad? Maybe. We're gonna have to redo it and then save it, but I think, yeah, we're gonna have to pair these points to these edges, and then we calculate tessellation amount per edge and inside and stuff like that. But first of all, we begin with view vector center, and we do tessellation exponent inverse. We do lerp 0 tessellation amount pow, and our t here is going to be inverse lerp between tessellation distance tessellation distance bounds dot x tessellation dot y and the length of view vector. So let's draw this, make it make sense. Basically, we have a point that is being seen from our camera. We Yo, what's up, Jax? We calculate the length of this one. That's L. And then we have defined our a upper bound and a lower bound like this. That's our tessellation distance bounds. Julian, thank you for the follow as well, appreciate it. D2, or it's actually dx dy. So given a point here, so we take this length and then we do inverse interpolation between these two values. So in this case we will get we will actually get 1, so we need to flip that one. But if the point were located here roughly, or here, our inverse slurp would result in 0.5. If it were located here, it would be 0. So I think we can just do, first of all, we need to do inverse slurp saturated, or inverse slurp 0.1. We want to threshold it between 0 and 1. And so if this one is big, we get 1, so we just want to flip these as well. So the smaller this one is, the closer to this value we are. And we'll do tessellation exponent, put it here, and that's about it, I think. But then again, we only use the center point here, so... Oh yeah. This is a float 2. Okay, we probably want to be a little bit nicer to this, so I'm thinking 5 and 100. Okay, 100 might be a bit too much, 20. So now we are more than 20 meters away from the quad. And then when we get closer, we tessellate, 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 and that's about it. This is also one thing. So we do normal calculations on in the geometry shader and the domain shader, which means that when we're far away and look at something like this, we get pretty shit normals. So we're probably gonna have to... So for instance, if we have a terrain patch that is at its higher resolution, it's 258 or 261 times 261. When we are the furthest away from it, we're probably still gonna keep it sorta high, but not too high. So I'm thinking maybe 32-ish or something like that. That's one solution. So we can't de-tessellate it as much as possible, because then we're gonna get some weird offset. I mean, seeing a mountain in the horizon that looks like this doesn't really sell it. It's not very good. But something like this could probably... we'll see. Another solution, of course, the normals are gonna get the most screwed up, honestly. We could probably smooth them out by going down in MIP levels. Or one solution I've been having in the back of my head for a long time is also the fact, or is to calculate... We do a pre-pass that calculates the normals. And I'm a really big fan of that one, so maybe we even use a compute shader to calculate normals. So that would mean that we only... So right now we recalculate normals every frame. But doing the pre-pass would be... So we alter the terrain. And we alter the terrain on the GPU as well with a blit command. And when we have done that, we add the pre-pass that goes through the full texture and recalculate normals using a compute. If we use a compute shader, we can probably just recalculate a portion of the texture as well. And then we read that normal texture when we render this terrain. Because if we do it like that, we can read the normal texture in the fragment shader, which will definitely add a lot of texture reads. But we don't have to calculate or do anything like that. We'll see, we'll see. Maybe. But this makes me think... Yeah, the thing is, we're still gonna keep the lowest tessellation amount power, tessellation exponent. We're still gonna keep that at 0. It's just that the initial terrain mesh we create will have a higher subdivision. So right now we have a subdivision of 0. So we get one subdivision actually. One. So I wonder what would happen if we would go subdivision 2. We should regenerate. Ooh. Yes, we have to fix the seams, but we should So this is our smallest. Then we go and look at this terrain. Very nice. But the seams, yes. Okay, so the seams is because we tessellate based on the center of the quad, so the original quads. Let's go. So we check how far away is the center of the quad to the camera, and then we tessellate based on that. So but if we do it edge based, we should probably be fine. I was a little bit afraid of the you see the FPS drops we get here when I do this, but I think they are based on the fact that we're hovering above this one. Didn't see this in previously to Unit 6. If we just do this, it looks all right, but we don't have that's pretty good. It's pretty good. Okay, so let's see what we can do about the seams. I want to be able to test this a little bit better, so if we go... and... zero. Or 2, 5. Yeah, so if you take a look at this one, this is subdivided x times, this is subdivided x plus 1 times, and we get this. But we're gonna fix that thanks to the basing the tessellation amount on the edges instead. Reading, I'm copying your style in VS Code, hoping to increase my programming skills. Nice. Yeah, I like this this layout. It has improved it quite a lot, instead of tabbing between Chrome and stuff like that. But can't find the theme you're using. It's very cool. I think it should be just a default one, but one sec, let me see if I can get this. Where do we have themes? Why can't I seem to remember? Let's go here. Theme, VS Code. File preferences theme, okay. No. File. Preferences. theme. Color theme. I think it's dark modern, default dark modern, so it should come with VS Code. The only difference, I've customized it one thing in it. I've customized it to have the same background color as GitHub, pretty much. I like this gray more than the gray you got with the theme. That's pretty much it. Okay, so this one should be an easy problem to fix. We're gonna start by exiting this and go here. And what we want to do, and mind-blowing indeed, is we pretty much want to split these like this and calculate them each individually. The problem here is going to be to find which edge is which. So we're gonna figure this one out. I know we have already done this once before. Unfortunately, I didn't save it, so my mistake. We're gonna do it. We're gonna save it here. So if we have 1, 2, 3, 4, 5, 6. If we have a nice square like this, and then we do this and this. Okay, so around here we have 4 points and 6 edges. 1, 2, 3, 4, 5, 6 edges. We are gonna figure out which one of these pairs with which one, and we have vertex 0, 1, 2, 3. That's these 4. And then we have edge 0, 1, 2, 3. And then we have inside 1, 2. So inside 1, 2, and then edges. Yo, what's up, Habuka? Okay, so how can we do this real quick, real easy? Edge 0, 1, 2, 3. 1, 2, 3. We can probably figure out quite easily. Actually, I'm gonna add this one as well. This one, we're gonna put this one here. I'm gonna try and make these images nice and clean, because what I want to do eventually is I want to take all of these images, export them in a nice way, and we're gonna put them in this issue right here. Like real structured, summarized, what we do, how we do it, explained with some nice figures. Okay. something like that. And very OpenGL type colors here. One thing when it comes to interpolation, so what I'm drawing here is the UVs for the full quad, basically. Let's see here. I wanna move this one down to here, and then we're gonna do this. Okay, like this. Maybe I want to visualize it. This. And this. Okay, so on the CPU, we generate this quad, which is actually 4 quads. And we assign it we assign the vertices here a UV based on this. So this point will have a UV of 0, 0, 0, 0.5, 0, 1, 0.5, 0, and 1, 0. When we do tessellation, so this UV I have explained here is this UV right here. So this is what we send down to the GPU. And then we interpolate this one all the way through. So a pixel around here will almost have a 1, 1 UV coordinate, okay? But when we do tessellation, we introduce a second UV coordinate. And this one is per sub quad sent from the CPU. So this UV here, so when we tessellate and we want to calculate a point here, we calculate that point's properties based on these 4 points. So the UV here is per sub quad. So this one has a UV that goes from 0 to 1. This one has a UV that goes from 0 to 1, and so on. But we found out that it's not aligned like this. If I remember correctly, I think that UV actually does this and this. I even wonder if these arrows are flipped, so we have 0 up here and 1 down here. So that's also something we want to figure out, okay? And put into this nice little figure. So let's begin with this UV right here. And to visualize that one, we're just gonna do our domain shader output has color here. Do we use this one? Color? No. Okay, so what we're gonna do is change this one to 1. I might have wanted to add these as well. So in the domain here, we want to do output UV. We want to do output.color is equal to float 4 UV tessellation 0, 1. Create point from. Ooh, did I fuck up? Ah, we don't use that one, so that doesn't really matter, but... something like that, and then in our fragment shader we just do return input.color. Yes. So here we can see what world coordinates do we have. Like this. Okay. I was spot on, I think. So for each subquad we have UV 0, 0 down here. Here we have 1, 0. And here we have 0, 1. So it's pretty much exactly like this. Wonder if I want to do this just to visualize where it ends properly. Okay, so that's it for our UV coordinates. That looks nice. Okay, now let's move on to V0. So I want to figure out which point is which here, and we're gonna do it by hull shader patch constant function output. We're just gonna do float 4 color. How can we do it here? No, we can't do it here. One sec. We don't want this one here, but we want it, so we can use the old color value we have. Nice. So here, instead, what we're gonna set is, we have the patch here. So let's do color is equal to I'm gonna assume that the order of these patches are the same as here. I wonder if that is that a bad assumption to make? think so. Let's try it. I will hopefully notice if we okay, was thinking about doing an interpolate bilinear here. That will get our UVs. How do I want to do this? Vertex shader output, probably want to hull shader control point output. Yeah, we want to make sure these vertex shader output how can I test this? Okay, I wonder if we can do it like this. Hull shader control point output for patch. hull shader control point output. Let's do it like this. And then we do like this, and then output color we do interpolate by linear. Copy this. Hopefully, let's try this. Now I'm doing valid subscript dot color hull shader control point output. Can't we change these? Actually, I think we should be able to just do this. I hope. But then we could have derived it from the UV, so I don't know, this doesn't really give us anything new. Red. Red, green, blue. Zero, 1, 2, 3. Is that it? Can we do anything here? I'm not entirely sure I trust that result, but we can do... what the fuck, we can do this. Position center. Can we... Let's just work with the assumption that that is the correct order. Although, yeah, I don't know if I recognize that, but B1. B1. 3. No. V0, V1, V2, V3. Okay, the edges should be a little bit easier. We're just gonna do it like this. Test. 1, 2, 3, 4. 0, 1, 2, 3. And then we do this, I think. Quad 1, 1, 1, 1. Is this the original one? What did we have? Subdivision 2. 1, 2, 3. 1, 2, 3. Yeah. So I think these 3 are actually. It looks sorta fucked to max height. We're gonna go with 0. There we go. Okay, so I think we have 4 original quads. This one, this one, this one, and this one. So if we, what do we have? X said, if we tessellate edge 0, we get this. Which I remember. So I fucked up this one. Oops. We actually want to locate this one here. Here. And then we do edge 0. Let's do it like this. Edge 0. Edge 1. Okay, edge 0, 1, 2, 3, and then let's do the insides as well. wonder how weird this will be. We're gonna do test. I'm gonna have 0, 1. Fuck, I hope this is true independent of hardware. Yeah, I hope so. 1. So, test. Okay, that's a little bit hard to see. Okay, so edge 0 is this one. So edge 0 or input 0 is the one between 0 and 2. There we go. Okay, so now that's out of the way. And we're doing this because for each of these points, the vertices, we're gonna measure the distance to the camera, and we're gonna set a tessellation amount based on that. We've done it previously. And then I think... I'm not sure just yet how we want to handle these inner ones. But we will probably take... Fuck, now when I think about it... Yeah, so with these vertices we can define each of the lines individually. So if we take line E1, I wonder if we want to find the closest point on this edge to the camera, and then we take the distance of that point to the camera, and that's how much we tessellate it. Because if we base it on these points, I thought about the situation when the camera is located at roughly at E1, which means that this one is very far away and this one is very far away from the camera, but the edge is actually extremely close to the camera. So yeah, we probably want to calculate the lines or define the lines, which we can do with the points, and then we calculate closest point to the camera and tessellate based on that. Closest point on line, or closest point on line to another point. Okay. Normal vector. Okay, let's see. Since the shortest distance from an external point to a line is along a perpendicular. Yes. This is under the constraint that xy is on the given line. Okay. Do we... the normal vector here is... So the normal vector would be our v0 minus v1, for instance. Okay. So we say the closest point xy. Yes. This vector must have the same direction as the normal vector. Okay, so the normal... Yeah. Okay. We don't have infinite lines though, but that should... Ooh. Yeah, we don't have infinite lines. Can we rework it so we don't work with infinite lines? Maybe. just have to, if we work with this as if it were an infinite line, what would that leave us? So for instance, we have a point here and we have a point here. These make up the edge. Our camera is located here, which would probably mean that we would get this point. So that's not correct. But if we have this point, we could probably threshold it to this point, right? Pretty easily. But if we have these points, infinite camera here, we get this one, camera here, get this one. I'm wondering if we could threshold it with inverse lerp, but that would probably leave us with, yeah, that would probably work, right? So we get this point, and then we do inverse lerp given these 2 points. Which will bring it back to here. Am I missing something here? Is it just thresholding the X and Y? Okay. How long along the line we will go? Ah, that's beautiful. Then we can just line point, line direction, and then we threshold this one at 1. And then we're done, I reckon. We'll threshold it by between 0 and 1. Line point, line direction. Point. Okay, let's try this one. Do we need to normal? Yeah. Okay. Let's implement a method that does this. So load, find distance to edge. Float 3. Yeah, we want to do this in world space as well. So edge point, float 3, and let's do it like this. Find distance to edge. Edge point 1, float 3, edge point 2, and float 3. Find distance between edge and point. Find. So we do float 3 edge direction is equal to normalize. Always forget this. Is it edge point 2 minus edge point 1? This, and then we do float 3v, we can call it v, and that's equal to our point minus line point, so edge point 1. And then we do float t is equal to it's not t, like it is t. And direction. Don't we want dot product v line direction? Doesn't that leave us with a value between -1 and 1? Ah, okay, okay. Same. Oh, one sec. So this is pretty much what we wanted to do. So yeah, let's calculate the length, edge direction, do this float. It's not really T, it's D. But one sec. We can stop here. We actually don't need this. We just need this. Or no, that's not entirely true. But we should be able... I wonder. We could probably opt out. Okay, so if we were to go the long way of this, we would do float 3 closest point on edge equal to edge point 1 plus d times edge direction. But then we do not here, and we do lamp clamp this one to 0 and edge length. Something like this. This gives us the closest point on edge, and then we can do return length of closest point on edge minus point. But I wonder if we could simplify this a bit. And also, can I visualize this? It would be nice to be able to visualize it. Let's do float I wonder if I would like to visualize this one. Closest point on edge. Just to make sure it's valid. Something like this, and then we do float 3 or edge point vs. edge point 1, edge point 2 point. Okay, so for edge 0 we do v0 v3. So patch v0 position vs patch 3 position vs, and finally the point in question is gonna be our camera, world space camera position XYZ. One, two, three. Okay, so for 1, v0, v1, 2, v1. I'm a little bit, I don't know if these are the correct ones, but I think we'll be able to find it out here. v2, v3. Yeah, we do these calculations. Does it make sense? Yes. And then domain shader final color, we are gonna do, wait, not here. Output dot color is equal to we wanna do first of all, we want to calculate this one. Closest point. Does this make any sense? I think so. Factors dot edge point vs and then we do inverse lerp 0, 0, 1, 1, 0, length, closest point vs world space camera position XYZ, but do that here, edge. Yeah, this is not the edge point in VS. Oh, yeah, it is. Yeah, it is. Okay, I think we can do it like this. Unexpected token. Okay, if we want to do this up here, we're gonna have to move. We have this one here. 1, 2, 3. What am I missing? Hmm? $249, but we also get a error here. Mm. It's wrong. Wait, can't we name anything to point? Is that seriously? Okay. Yeah, maybe. Length, no matching to parameter. Where do we have length? Yeah. Minus. Invalid position here, yes. We want to use think. Okay. Yeah. That's not really what. Okay. 1. That's Linky. What's up? Okay, I like this. I just want to... Oh yeah, can we tessellate it a bit more, maybe. Nah, not a very big fan of the fact that... Yeah, this is wrong. Not the best way to visualize it, but we can... We're not getting very good result here. How can I visualize this? Yeah, this is per vertex. Ooh. I want to visualize it by... I want to highlight this vertex. Edge point. We get the closest point to the camera on each edge like this. I'm pretty sure. How can we visualize it? Not like this, that's for sure. Inverse lerp 01, yeah, that's wrong as well. We want to do distance. Why maybe? Not at all what I want to see. I don't know if we can visualize this the way that would be if hmm. Mm-mm-mm. Okay. Okay, we get 4 points here. Closest point vs. We don't want to do this tessellation here. We want to figure out, when we calculate this point, we want to see which one of these 4 points is it closest to, and then we send that onwards. Do we do it in the domain shader? Yeah, domain. Yeah, this part is just for debugging, so it's not something we're going to keep around. I just want to make sure that the correct point is chosen. So we're gonna do it like this. Domain shader output. Why didn't I get your layout in VS Code? Now I'm a hacker, now I have the power. Congratulations. Enjoy it. Float 3 closest. Position 2. So for now, I think we're just gonna do it like this. If factor zeros minus this length is less than length. Output dot closest point. Closest. Output.closest. Yo, what's up, John Olsen? Is still knee deep in snow? Not yet, but soon. We're refining. We're doing the last things with this tessellation, and then we're gonna apply it to the snow. And hopefully enjoy being knee deep in snow. And then we just want to do this 4 times. Oh yeah, one more thing. Okay, so now we output closest here. And create point from. Really hope this visualization works. So all the way through we send down the closest point at all times. Do it here. 2 closest. Like this, and then I want to color all of this based on closest. So we're gonna do return inverse lerp 0 and 10. What's this error? Array matrix vector indexable object type expected in index expression. Factors. What's wrong with this one? Ah. Dot edge point world space, and then we remove these. Of course. So can we do, let's call it length. Let's just call it L, and then it's these two, right? Jonathan, I work with game dev professionally too. I do this part-time, so I guess that question would be a 50% yes. Come on, how many errors can I produce? What did we have here? Closest point, undeclared identifier. Oh yeah, we don't even do this anymore, so I don't think I care about that one. Okay, let's just go through this real quick. This is all very wobbly, but what we do is in our hull patch constant function, for each edge, we calculate the closest point on each edge to the world space camera, and then we send it down. So when we get to our domain shader, we have factors here. We have edge point, world space. So in the domain shader, then we just we calculate the output position, so a interpolated point, tessellated point, and then we figure out which of these edge points is closest to that one. And yeah, then we set that one to be closest. In the geometry shader, we just interpolate this one. Fuck me. I don't think we want to interpolate it like this. We never want to interpolate closest. That will screw everything up. I wonder if we want to do something similar to this. Probably yes. The two closest. The two closest. Output position world space. And T2, is this correct? Yes. And then we need to do this sort of stuff. Here as well. P1 and P2 is correct, but not output. Interpolated point. Interpolated point. No errors, really? Okay. Now I think we do it the correct way. Let's see what kind of result we have. White. We have it seems to work for some, doesn't it? This right here looks pretty good. This. No. Inverse slurp length input closest minus. Okay, something is. We're doing this in the fragment shader, so we should be getting. We shouldn't be seeing this blocky result. So the idea is. Maybe. Doesn't seem to be working in this direction. Did I screw up? Oh. Zero, 1, 2, 3, 0, 1, 2, 3. Okay, there's currently a lot of places this can go wrong. First of all, we're doing the assumption that this one is correct. 03011223. Okay, I know the problem. Or do I? World space camera position. Oh yeah, I do. So all the way through we send down the closest point. So which one of the closest points is this one? Yeah, that should be okay. But I used world space camera pos here. That is not the correct one. We want to do input.position world space. Ooh, okay, this is a better result, but still. Pretty cool, but not what I want. We can see here that two of our points are correct. So we can see these black dots moving by these. Those are correct. These two, so good, that follows the diagonal, they are wrong. Okay. So we want to calculate. Why did we get these two? Is my question. It's because. Yo, what's up, Yank? These points are not correct. V0, V1, V2, V3. Shader programming? Hell yeah. Our V0, V1, V2, V3 is wrong. V0... I think... Yeah, good job. Yeah, we're getting there. I never learned shader programming yet. I recommend it. I think, or usually, I think it's very fun. Love doing shader programming. Although, we've been doing it for quite a while now. We're talking months, I think. I'm growing a bit tired of it. So we're gonna have to vary it with something else soon. It's definitely a different way of thinking as opposed to your traditional programming. So I wonder, our E1 and E3, they seem to be correct, right? But then our E0, E2... what kind of game are you making? It's supposed to be like a cozy creature collecting game, much like Chow Garden in Sonic, if you've ever played it, or the Viva Pinata game series. Something of that sort. My question is then, how do we get correct? Did I screw this up? 0301. Cool, I'm also developer. Nice, nice. Yeah, that tends to be the people over on my streams. Or most of them, if not all, are developers of some kind. I really thought we did this test careful enough, but these ones, yeah. I wonder, V0, V3... Because we can see, okay, let's see, X said, so it's on our said. We have the correct right. Yo, PG King, good morning, yeah, good morning indeed. Jack, I'm making a psychological horror exploration crafting game. Nice. That sounds like a lot of work, similar to my game. And how's the dev going? It's going all right. We're finishing off the tessellation by doing the distance optimization, but we have some tiny bit of an error here. Like, I wonder, could it be... I get it. I think I get it. I think I do. Yeah, these points right here, this might actually be correct, V0, V1, V2, V3, but since our topology cuts the quad like this, we get these two lines right here. So I wonder, we can simplify it a bit. Or... when we get down to our domain shader, I wonder if we can just do... if we disable the split, where do we have it? Split quads 0. What do we get then? Or do we seriously still get... So you can see here that the line follows this one. How does it look over here then? Yeah, okay, what we're trying to print follows the topology. We don't want it to follow the topology. So how can we send down this information in a better way? But I'm thinking that we're doing RPG, are you currently working on the terrain things? Yeah. One could say that. It feels like I'm getting sidetracked a lot, but in the end, it's going to improve most of our terrain-related stuff. So our terrain or terraform system has been in a acceptable state for a while, right? But there has been some artifacts with it. One of them being topology. And this topology issue that we have on the terrain, it really showed when we were working with snow and deformation. So then we looked into tessellation a bit more, and that's what we're sitting with right now. We have really reached a good result on the tessellation. Now we just want to add the last optimizations, and then we're gonna apply this to all of our terrain related shaders pretty much. So terrain, snow, water, you name it, and it's gonna improve everything. That's the idea at least, but so right now we're doing tessellation based on view distance, so the closer we are, the more we tessellate. Previously we have always solved this problem by basing it on these points right here. This time around I want to improve on this one as well. So when we set the subdivision amount for edge 1, for instance, we find the closest point to the camera on this edge, and we base it on that distance instead of... Yeah, so if the camera was located here with our previous solution, we would get a low tessellation here because the distance from the camera to each point is very far. This time around we will find this point right here and we will tessellate it a lot. So what I'm trying to visualize here are these closest points, and we can see that they work on the sides here, this side and this side. But we don't have these points, and I think I don't know exactly where we go wrong, but we're gonna find it. PG Games, what will be your game mechanics ultimately? Are you collecting creatures by luring them in, or will you have to explore and grab them? I would love to do exploring and grabbing them, but that's not in the plans in the near future. So I would say not in the first version of the game. So instead, you sorta want to lure them, but that's maybe not the perfect word for it, but you take care of this garden, right? And you terraform it and build it so it's nice and cozy for creatures, and depending on how you build it, they will come and live in it. So basically it's a sort of city builder type of stuff, but on a more zoomed in level, right? So the best example I can think of is, so you get this plot of land, the first thing you do is you dig a big lake. So now your garden is 80% water, which means that water creatures wants to come and move into your garden, pretty much. And then you have to take care of them, feed them. Stuff like that. Yeah, I think it will be very nice. That's why I really put emphasis on this Terraform implementation, because it's going to be a big part. I really want to make it work well and look good. Okay, but for that to be able to do that, we need to figure out why we don't get these points, why we get these diagonal points here. Yeah, exactly. So it's gonna be lower and heightened terrain, plant trees, grass, create rivers, yeah, you name it. Okay, so 0, 1, 2, 3. Yes. Calculate distance between edge and point, and then we return these 4. And we get to this one, we calculate a point. This one. And then we check which one of these 4 is it closest to. Okay. Or really? I wonder what happens if we just do this. Domain shader. Let's do this. 0, 1, 2, 3. And then we do, instead of doing this bad check here, we do like this, and then in the fragment shader we do this. But let's see. So we do like this. In the geometry shader, if we don't split, we just do this. So we send it in onwards. And then here we do this. But we change input position vs of the 3 closest. Closest 0, 1, 2. Then we have this one here as well. Oh well. Yes. Then we just need to do position 2, 3, 4, 5. Come on, output. Do we still use output here? Yeah, we do. We seriously still get diagonal lines. This makes me think, very cool. This, are we accidentally creating Voronoi noise here? Sure as hell looks like it. Oh well. A bummer that Voronoi noise has already been discovered and defined. Otherwise, I just love this noise. But okay, These diagonal lines, we still have the same diagonal line problem as we did previously, but this time around all we do here is we send this onward. So domain shader output, yeah, new old feature added. All we do here is we take our edge points and we send them onwards, pretty much, and then we don't use them until in the fragment shader. But this tells me that this is wrong. These points here are wrong. Which one? So if we do 3, 0, 2. There we go. But okay, let's do this. 0, 3, 0, 3, 3, 3, 0, 0. Okay, 0, 3 is wrong. 0, 1. Okay, 0, 1 gives us edge 1. Zero, 1, V2, V3, 2, 3. Um, 2, 3 gives us yeah, 2, 3 gives us edge 3. Three, 0, 1, 2, 3. 0, 1, 2, 3. And then I thought 0, 3 would give us this one, but it gives us this. Zero, 2. There we go. 0, 2. Okay. 3, 2. There we go. Edge 0, and then the last one then should be V1, V3. 1, 3, and that gives us edge 2. And then if we add them all together and we change that's fucking beautiful. Okay, great. But. I'm still a little bit scared of what would happen here. So for this one, this edge gets subdivided. So this edge for this square gets subdivided as many times as this edge for this square, and that's good. This edge and this edge, same amount as well. But this point right here won't get subdivided as many times as this point right here, but that's okay, because this point still exists for both of them. This edge right here will be subdivided. Okay, nice. I think we can rely on these points. Very cool. Yeah, what's up, Jax? Still streaming, bro? Yeah, I'm gonna go for another 20 minutes, then I need to run. This looks beautiful. Okay, so we pretty much did all of this debugging and fixing related to these, just to make sure that this method right here does what it says it does. It doesn't even really do that. It should be calculate closest point on edge to point. But that's okay, because we are gonna change it so that it actually returns distance. Because whatever happens in this one, we are gonna use for these. Yes, so we are gonna do calculate distance between, one sec. Calculate distance between edge and point. That's not really what we want it to calculate. We actually want to calculate this point. Or no, it does exactly what we want it to do. If we do this. Okay, and these are correct now. V0, 1, 2, and 3. So what I want to do is, so for edge 0, we're gonna do The game based on shader, yeah, definitely. Let's do float, edge, 0, distance. Calculate distance between edge and point. The point is always going to be camera, world space camera position. And then we're gonna have patch 0.position vs patch. Okay, so here we have to be careful. So edge 0 is v2, v0, v2. So then we have the distance, and we want to do the same thing for all of these. Edge 1, v0, v1. Edge 2, v1, v3. And edge 3 was v2, v3. Like this, so then we have the distance, and what we want to do is tessellation exponent. We're just gonna name it float exponent 0 is equal to lerp tessellation amount power 0 . Distance edge exponent, then lastly we're gonna do how to round. Is it like this? How to round tessellation amount. How? Okay, we haven't solved the inside yet. Wait 1 sec, what? Oh yeah, we don't call it point anymore. Now when we get closer to this edge, we subdivide it much more than these. And we can see here that the seams are working beautifully. Move closer to this one. We haven't fixed the inside just yet. We're gonna do it soon.
But when everything is coming back to me, I feel as if my memory is paralyzed.
Now let's see. What is the last thing you can remember?
I don't know.
Great. Although I should be okay.
Go on.
Do okay, this looks great. Okay, so I want to fix the inside now. The question is, the closest point on this line, can we derive it from the closest points of the... So this point is made from this line and this line. I think we're going to calculate it for that one as well. Although it's going to be a little bit more complicated, but let's see.
Oh, wait a minute.
Distance inside 0. Exponent inside 0. Okay. The thing here, when we calculated this line, we first need to calculate the points that make up this line. So for inside 0, we need to calculate this point and this point, and that's just a lerp between v0, v2. So lerp do it like this: lerp position 2. What is it? v1, v3, 0.5, and 0 and 2. Oh, we can do 0, 2 here. Then we lerp again. Did I screw up my parentheses? Oh yeah. Distance inside 0. Lerp one point, lerp another point. Those make up the line. Yes. You can probably put this into some sort of method later on. Inside 1, inside 1, inside 1, inside 1, inside 1. And then V0, V1, and V2, V3. And here we have it, I think. I'm a bit afraid of one thing, though. Which I guess most of tomorrow will be about. And that is when we get something like this. I'm not sure if our current implementation of in the geometry shader, so the final tessellation can handle this. But this doesn't actually look too bad. Maybe. Huh. We'll see. We should be able to fix that. Can we get... yeah, I think it fucks it up. Yes, it does. Actually, this one is a little bit... You know what? This might actually work. This point right here, yeah, it's a middle point. This point. Yeah, we get some extremely ugly triangulation, but as long as... This is very weird. Why we're getting this here. Okay, yes. That's because we're extremely close to this triangle, but extremely far away from this triangle, so we get more. Okay, this we might not want to do the inside triangles like this. The inside triangles we would probably want to do, or inside edges, I mean. We probably want to do it like we did previously. So we take, so for this one, we take max of E0 and E2. For this one, we take max of E1 and E3. And then for both of these, we do the max of that result. So these two should always have the same subdivision amount. And it should be the max edge they have, I think. I think that's it. But I think that's the solution. But I'm gonna leave on a little bit of a cliffhanger. We're gonna see if that is the solution tomorrow, but I'm gonna continue my day as if it was. So I'm gonna be happy. This feels great. Everything looks good so far. This is gonna be real useful. We might even be done with this earlier this week than I expected, but we'll see. Yeah, thank you so much for watching, everybody. I appreciate it, and have a great rest of the day. Peace.